So first thing is you draw the tables, and after that, you're just going to look at the beginning and ending vertex. So you're going to begin at A, okay, circle where you begin, and then you're going to end at D, and then circle where you're going to end, and then start to write down the distance. Okay, so the distance from A to A is 0. Okay, so because you used A, and then you're going to delete all the rest, okay, just by drawing a vertical line. And then after A, you're going to label all the distance. Yeah. So we have A, B, C, D, E, F, G, which G in the middle. Yeah. So we're going to label all the distance. So A is adjacent to B, A is adjacent to G, A is adjacent to F. Yeah. So A to B distance is 6. A to G distance is 9. And then A to F distance is 4. Yeah. So when they are not adjacent without the distance, you're just going to using infinity to represent. Okay, using infinity to say if we don't know the distance. And then I'm going to conclude step 1. So the minimum one is going to be your conclusion. You circle it in a box. Okay, so draw a box to do a conclusion. So that is our final answer. Yeah. And then we know we're going to add vertex F now. Okay, so let's add vertex F, and we're going to have a look at what does F adjacent to. Okay, so F, yeah. First of all, we used A, we can never come back. Anything you use, you just directly cross that out. F is only adjacent to G, and F is adjacent to E. Okay, so let's do them one by one. So F is adjacent to E, so we can label E. It's originally 4 plus a new 4, that's 8. So that's 8 calculated from F. And then we can also do G, 4 plus 3, that's 7. So it's 7 calculated from F. So when you have 9A and 7F, so you only update if the number is smaller, otherwise you copy the initial number, okay? All the others you know. So, but by the way, when we add F, we're just going to delete all the one for F. Yeah. All the others is not adjacent to F, which should be infinity. Although you want to write 3 infinity down, but you know if there's a number smaller, we're just going to copy down the original number. So instead of doing 3 infinity, you only do 2 infinity. And then this one, I'm just going to keep the 6A, okay? And then now let's decide next, let's decide the final conclusion. We find A is the smallest. So we, next one. Okay. We're going to use this as our final conclusion. So it's just A, yeah. So this 6A is from where? Is from B. Is from B. So now we're going to add B. As soon as you add vertex B, yeah, because F is finished, you delete F, you're never going to come back to F. And then because you add vertex B, we never need to calculate the distance again, draw a vertical line, okay? Now let's look at where B is. So B is only adjacent to G, and then B is also adjacent to C. Okay, so let's write down the distance to G and then to C as well. So B, remember, it's 6 units from A. Yeah, so 6 plus 2 to G is 8 units. Okay, yeah. Although you want to write an 8B, but the previous answer is 7F. Okay, so if the number is larger, you don't write it down. Okay, you're still going to copy down the original number. You only update if the number is smaller. Okay, yeah. And then B is also adjacent to C. 6 plus 9 is 15. Okay. 15 is less than infinity, we're going to put down 16B. All the others, they are not in adjacent, we're going to copy down infinity, but here already have a number, we're going to copy that down. Okay. Now let's have a look at what is our smallest number, which is 7F. Okay. 7F, and then we know which vertex we add. We're going to add vertex G. Okay. So let's add vertex G. Yeah. So when we add in vertex G, we already used B. Make sure you go back to the graph, delete B. Yeah. So what does G adjacent to? G now only adjacent to C, adjacent to D, adjacent to E. Okay, adjacent to C, D, E. And then once we add G, we're going to delete all the rest. Yeah. So let's have a look at it. Okay. So the G distance is 7. 7 plus 5 is 12. Okay. So it's 12G. And what's the distance G to D? Yeah, it's 7 plus 9 gives us 16. Right? 16 is better than infinity. We update again. Yeah. And then distance from G to E, 7 plus 5 is 12. But 12 compared to 8, 8 is smaller. So we're going to write down and 8. Okay, we're still going to write down 8. Okay, and then draw our final conclusion. Which one is smaller? 8. Okay, 8 is smaller, so we can decide what we're going to do next. We're going to add E. Right? Yeah, we're going to add vertex E. So let's do E. Okay, yeah. So once you add E, you're going to delete the rest. Yeah. So what does E? Yeah. Well, we can see when we use the E, we finish using G, we need to delete G. So E is only adjacent to D. Okay, E is only adjacent to D. E to D is another 10. So 8 plus 10 gives us 18. Okay, yeah. However, 16 compared to 18, it doesn't become better. Okay, we're just going to keep 16. And then E and C, they are not adjacent. We should put the infinity, but 12 is smaller than infinity. We're just going to put down a 12. Okay, yeah. And then finally, compared to 12 and 16, which one is smaller? Obviously 12. Okay. 12 smaller. 12 smaller means we are going to add our vertex C now. Yeah. So adding vertex C, you delete C, so there's only one thing we left. So let's do C to D. Okay, it's only 3 units. So 12 plus 3 give us 15. Okay, so there's no more one number left. That's going to be our final number. Yeah. And then we know this is just going to reach our distance D. Okay, yeah. So we know the distance is just going to be, so to reach D, okay, yeah. So this should be the only thing left over in the end, because you're trying to calculate the D and you should only left with D. So this should be the only left over. Okay. This should be the only left over because we just wanted to end at D. Now you know the minimum distance is 15. Yeah. So once you figure out the minimum distance is 15, and then you're just going to backtrack. Okay. Yeah. So let's start to backtrack. Okay. And at D. Okay. Yeah. And at D. Where does D come from? D is come from G. Okay. Yeah. So we're just going to say, okay, D is coming from G. Okay. Yeah. Where does G come from? Okay, where does G come from? G is coming from F. Okay, so G is coming from F. And then backtrack again. Where does F come from? F is coming from A directly. Okay, F is coming from A. So once you finish the backtracking, you can just write down the forward path. It's A to F to G to G here is coming from C, right? G here is coming from C. Yeah. Yeah. Sorry, I just missed it here. Yeah. So D is coming. Yeah, I've labeled this one wrong. Oopsies. Yeah. This 15 here is from C. This 15 here is from C because the vertex we added C. Okay, that's a huge mistake. That's 15 is from C. Yeah. So let me just quickly fix this part. Yeah. So D is from C. Yeah. But yeah, next part just corresponds. So where does C come from? C is coming from G. Okay, we're just missing a C here. Yeah. C is from G. Yeah, and then to F to A. Okay, so we have G and then to C and then to D. Let's label the minimum path on the diagram. So the minimum path is go from A to F, which is goes to here, and then F to G, which goes to here, and then G to C, which is here, and then C to D, which is here. And then we can calculate the minimum path. The minimum path is going to be 4 plus 3 plus 5 plus 3, which gives us 15. And you can clearly see this is exactly the same as the 15C. We write it down here. And so that's the final answer for this question.